Okay, hello. Today I'm going to talk about volume controls and specifically just about how to use them and the different types that there are. I'm not going to go into the slew details for slewing. That could be another video. And I'm only going to do this for the Sigma 300 or 350. So right now I'm showing this for a 1452. I'm running here at the moment. So this also applies for ADAU 1467 family. Um, the Sigma 100 and 200s, that would be the ADAU 1701 or the ADAU 1761, both have very similar, almost identical operation here, except those only have a type of slew called software slew. Um, the 1452 or the Sigma 300 350 cores have a slew accelerator built into the chip. And so the core doesn't have to do all the slew calculations. And so they have an option called the hardware slew. So let's jump right into this project here. I've preloaded this project, which is the basic starter project of subject of one of my older other videos. And this is a good, always a good project to start with. This already has a volume control on it. If I click and mouse over the bottom of it, it'll tell me what it is. Single volume hardware slew, HW slew. That stands for hardware slew. And I've already grown it to 2 channels. And so, yeah. So now, if I'm gonna, let me magnify this and get this on the screen so it's easier for you to see this. Let me pull this over like this. There we go. And, oh, actually, there's a problem because it's off the screen. There we go. That's better. All right. I'll get it right eventually. Okay, volume controls. I open that up. There's 3 different submenus here: adjustable gain, envelopes, and mute. We won't talk about mutes in this video, and I won't talk about the envelopes in this video. Just the adjustable gain. So you open those up, and again, there's 3 more types. And you see HW slew or SW slew. That stands for hardware slew or software slew. So that right there explains the differences between those two. And then obviously, no slew means, yeah, no slew. It means it just changes, it jumps right to the next volume or steps without a bunch of intermediate steps. So you'll hear zipper noise and stuff, but it uses less instructions. So if we look at, well, let's look at the no slew type. We just have 2 different kinds here: single volume or multiple volume control. Okay, single volume. This is where if I mouse over the bottom and I right click, I can add another algorithm, no slew, and it has a single volume to control both of these. And it's not much different than growing the algorithm. So not much difference there. It gave me an error. If I go multiple, because usually just grow. If you pull out the single volume and just grow to the number of channels you need. The multiple control is the one you need to pull up if you want to have more than one control. Add another algorithm and gain no slew. See, it gives you the choice of which ones. And it adds a whole nother slider. And so one of these outputs, the top one will be the left slider, the bottom one will be the right slider, and the bottom input and outputs. You get no gain in instructions. It doesn't use fewer instructions. It's a little smaller on the screen. It might be handy in certain circumstances, but me preferably, I always, especially if you get the multiple channels, you start guessing which output is it. To me, I'd rather have separate controls and I can label them. It'll be left front, left surround, right surround, center, etc. If I have 7 of them, rather than growing this to be 7 wide and then guessing as to which one's the left. Of course, you could put little labels, and I've seen people do little labels across the top using the user comments. So, personal preference, it's not a big deal here. You can do it one way or the other. But that's how that works. Um, and then the slew types. Okay, so the singles. Yeah. Do I need to really go into this further? No. The the single slew external volume is when it's externally controlled. There's a pin for an external control. Um, to do the external control, you're going to need to, usually you hook this up to an auxiliary ADC or something, so you have a volume pot. But it could be something that's adjusting according to certain parameters, calculating what the gain should be. Um, it gives you, it's your choice. I mean, it's whatever you want to feed into this pin. Um, and what comes into this pin is the gain factor, and we'll talk about that more in a minute. So I'm just going to grab a DC cell here and feed it with a DC cell so that I have something going into it. All right, let me put this in the field of view, and we'll I'll put this in, and then we'll start talking more specifically. I need to grow this because I want this to be 2 channels. So I'm going to grow 1. So remember, if you're just adding a channel, use the grow feature. And I'm going to hook this up so I can compile. And we'll have 2 volume controls, one right after the other. The DSP doesn't care. It'll do whatever you tell it to. Let me put this so it's obvious that the gain control's there. Okay, link compile download, and I compile download the program. Okay, the program's running. Now I can select the oscillator. I can bring the meters back into view here, and we can see we have output, and I can adjust the gain. Voila. Now, little things I want to show you here. In controlling these. I already mentioned if we go along the bottom here and right click, we get this add or reduce the algorithm for growing it or adding the algorithm. Like I said, usually grow is all you really need. And then you can copy. By the way, if you want to copy settings, well, yeah, that's a good, well, you can always copy. Let's say you set this up in a custom way. You can always right click here, copy it. Sorry, I'm going to be in the right place. Copy the settings, go over to another volume control that's the same type, the same kind, same size, right click and paste, and you pasted all your settings into it. So what settings am I talking about? Well, if you go over the middle here and right click, we have a menu of the settings. Now I can go right into here and enter the value, the current value. So I want to say, no, I want to drop this 10 dB, minus 10. Boom, it drops at 10 dB. And you see it sent in the capture window, it sent the instructions to the DSP to change the volume of the volume control, the object running in the DSP. Now here, you notice there's other parameters, max, min, and step size. These are not parameters in the actual DSP. If I go to the params window, this is called single 1, and it's, yeah, I think you can probably read that. If we go to single 1, we have gain, target, slew mode, and that's it. There's no other controls for single 1. We'll talk about those in a minute, but what these settings are for is just for the GUI, aside from the actual value, of course. The rest of these are for the GUI itself. You have linear dB. The linear used to be buggy and lock things up. I think they fixed those bugs, but I tend not to use it very often because it's not usually not needed. Okay, so here's where we got max of 0, which is often what you want. You don't want to go above the digital 0 of the signal coming in, but sometimes you want gain. And in this DSP, we can go as high as 42 dB of gain. So I can set this to be 42. Notice if I say, well, I want to go 50, it's just going to come back. Well, actually, let me do it. Don't try it though. It's going to give me an error if I actually try to do it. And then I can set the bottom scale. Well, let me make this more reasonable. Let's say I just want plus 10, and I don't want to go to minus 80. I just want to go to minus 20, let's say. So I have a little more resolution. And then there's the step size. I'll go into step size in a second. So you see the bottom of the scale is minus 20, the top of the scale is plus 10. So now I can get more gain or I can get less gain. And let me put the oscillator was set to a little lower. And you see now I'm peaking the meter out. If I get to right around 0, I get the minus 3, the 0 dBFS of the oscillator. And if I go up, I'm clipping. Well, if I was going out the serial port, I would be clipping the signal for sure. And as I look at the oscilloscope here in the output, I see a clipped signal. You can't see it on the screen, but I see it on my scope here. Anyways, but this is handy if you're needing more resolution, you want to see it better on your screen, if something you want to manually drag. Okay, step size. This is, it's pretty high here in this case. A lot of times, oh, this is because I think I changed this in this project. Usually it defaults to 2 dB of step size. What this means, I'm going to clear the capture window here. I said I'm going to clear the capture window. What this means is when I click and drag this, it's going to wait for me to change this by 2 dB before sending out a command out of the port. So if I were to look at these commands going out in detail, you would see it going up by 2 dB, 2 dB, 2 dB, 2 dB. And it defaults to that. And so now if I look, it says 4 dB. If I say, well, look, I want to set this to 1 dB. Click off, right click back. Look, it says 0. It didn't set it to 1. It went to the closest multiple of 2 dB. So this is word to the wise. If you say, well, you know, I'm going to do an EQ and I want to do, gosh, I'm going to do something accurate. I want I want a quarter dB down. So I'm going to 0.25 and hit enter. Well, actually, hold on. I had 2 decimal points there. 2.5. And I come back and I look at what it actually went to. Well, it tells me it did 0.25, but actually I don't believe it. Usually what you have to do is set this to 0.25 as well. Then it will do it. But it's going to send a lot more traffic as you adjust this gain. So this is a trade-off. You don't want to lock up your serial port or over the USB-I can get a little overwhelmed with traffic sometimes. So so you want to be careful with some of the USB traffic. So that's what that setting's for. I just wanted to give you a little word to the wise there because sometimes that messes with you. But that's how you basically use the volume controls themselves. Now, what is let me see. What's going on here is there's what is this sending? It's sending what's called a gain factor, and yeah, I guess I can go into that here. If I pull in a different screen here, here's Analog Devices website, and we go analog.com. So you go to Resource Library, Interactive Desktop Tools, and you have utilities for a dB calculator. I think you could search dB calculator. It's very handy. So it'll tell you the voltage gain and the dB. So if I want to do minus 6 dB, I hit enter. it's going to give me what's called the gain factor. The voltage gain is 0.5, so we're multiplying by 0.5. Well, it's 6.021, I believe it is, um, to get exactly 6 dB, exactly 0.5, or exactly half the gain. Um, if I want to add 6 dB, so I go plus 6, it gives me almost 2, so it's almost doubling the voltage. So 6 dB will double the voltage. Um, so this is what, yeah, I wonder if I did 0.021. Yep, see, it gives me 2. Um, so this tells you the gain factor. So this is handy if you want to do something like, hey, I want to go minus 14 dB. What's the gain factor? Okay, 0.1994. So that's what you got to multiply by to lower the sample by 14 dB. You multiply by 0.1994. You can do this through the dB formula if you care to. Um, so if I were to look at the parameters and say, this single one, let me see here. For slew, by the way, when we change it, you're going to see it's the target that's changing. The gain itself, you don't change that. So if you're using a microcontroller, you're going to write to the target, not the gain. Because the gain, let the DSP deal with that. The DSP is going to change this as it goes along. And as it slews, it's going to change the actual gain. So I'm going to say minus 14, enter, and let's refresh the memory, and you see the target was 0.1995263. So there was some, I had 1994, so there's some roll off in the calculator, round off, or truncation errors. You get that a lot between calculating spreadsheets or online calculators and what Sigma Studio does. It's something common to have to deal with. But anyways, this, so you see it set the target there, and if I refresh again, you're going to see the gain actually did get set to that eventually, because it'll slew to it. So to write, you write to the gain, you write a gain factor. That's how this works. That's how volume control works. So all the program does is it takes that memory location and multiplies it by the sample coming in, and there you go. You've changed the gain of the sample. So moving on to this externally controlled one, what's going in here is a gain factor. So the program, the DSP program, when it comes to this time in the program, it grabs these two samples coming in and it says, what do I multiply it by? And it says, well, what's coming in on this pin? That's what I'll multiply it by. That's it. That's all it does. So if I say a 1, it's gaining it as a 1. Hold on, let me put this back to 0 dB here so we can see plus, minus 3 on the meter there. Yeah, if I change this to a 0, boom, it goes away because that's a mute. It muted it. I'm just going to go to the DC cell and put in the gain factor. So if I want to drop it by 6 dB, that's roughly half, it's 0.5. So I'm going to go 0.5 and boom, minus 9. You see, so we entered the gain factor. I'm not putting the dB in here, I'm putting the gain factor. So if I say 0.1994, that was roughly 14 dB. So this should say minus 17. There it is, minus 17. And if I want to add gain, if I wanted to add 6 dB, I would multiply it by 2. And boom, this meter's set to only go up to 0. So let me change the setting of that meter to go up to plus 10. And now it's going to read, see, it reads plus 3, which is 6 dB higher than the minus 3 for 0 dBFS RMS. So you see how that works. It's just the gain factor. And so you have to be hip with the gain factor. Like 0.1 times 0.1 should be 20 dB down. Oh, it's minus 1. 0.1, and now it should be 23 is 20 dB down, because point 0.1 is a factor of 20 dB. So anyways, that pretty much explains how the volume controls work and how an externally controlled volume control will work. And don't forget to hit like and hit subscribe if you're not subscribed already. And have a great day.